Today we're going to finish up Chapter 9 notes. So we're on page 5, Section 9.8, finding two values of theta given its trig function. You want to have your TI-84 graphing calculator with you and make sure that you are in degree mode. Okay, so just check the mode. If you're in radians, if radians is darkened, arrow down and over, and darkened degree. All right. If you are given the sine of theta, the cosine of theta, or the tangent of theta, you can find two values of theta between 0 and 360 degrees. These two values of theta come from two different quadrants, depending on the All Students Take Chemistry. These are the steps. Use All Students Take Chemistry to write down the two quadrants your answer will come from, based on whether the given trig function's value is positive or negative. From the calculator, you get a reference angle by using the inverse trig function, or inverse trig button, meaning second and then the trig function, using the positive given trig value. The calculator will display the reference angle for your two answers, and then use the following formulas for the quadrants to determine the final answer. If your answer is from quadrant 1, use the reference angle as the answer. If it's from quadrant 2, you take 180 minus the reference angle. Quadrant 3, 180 plus the reference angle. Or if it's in quadrant 4, 360 minus the reference angle. Seems like a lot, but you'll catch on. Okay. So here we have, for example, for each function value, if theta is greater than or equal to 0 and less than or equal to 360, find the nearest degree, two values of theta. So we're finding two values of theta. So we have here the sine of theta is equal to this decimal value. Well, this decimal value is positive, right? It's a positive value. So using All Students Take Chemistry, our sine function in what quadrant is sine positive? All right. Sine is positive in quadrants 1 and 2. So step 1, note the quadrants, quadrant 1 and quadrant 2. All right, I'm going to spread them out like that. Next, from the calculator, we get the reference angle. So we key in second sine of 0.5839. So second sine 0.5839. This is the reference angle, and we want this to the nearest degree. So 35.7 will round up to 36 degrees. All right, what did I do there? I did second sine on the calculator of 0.5839, and that was equal to 35.72531, so on. So this is 36 degrees. This is our reference angle. All right. So if we're in quadrant 1, a 30-degree reference angle would be its own reference angle. And if we're in quadrant 2, if we have a 36-degree reference angle, the actual angle itself would be 180 minus 36 degrees, which is 144 degrees. So these are our two values. These are our two angle values, 36 and 144. The next example we're going to work through, the cosine of theta equals negative 0.3828. Okay, this is negative. In what quadrant is cosine negative? Cosine is negative in quadrant 2 and 3. So quadrant 2 and quadrant 3. Now we go to the calculator. We actually need to find the reference angle. All right, step 2 is finding the reference angle. So we key in second cos of 0.3828. You don't put the sign, you don't put negative. You just do second cos of 0.3828. Second cos, 0.3828, 67.4927, 7.4927. Rounding to the nearest degree would be 67 degrees. That's our reference angle, right? Always a reference angle is going to be less than 90. Now, in quadrant 2, if we have a 67-degree reference angle in quadrant 2, well, what is the actual angle that shares the terminal side there? It's 180 minus 67, which is 113. And for quadrant 3, do 180 plus the reference angle, 180 plus 67, which is 247. So here are our two angle measures. Next, the tangent of theta is equal to 1.2435. Okay. This decimal value is positive. It's a positive value. Tangent is positive in what quadrants? Quadrant 1 and quadrant 3. Quadrant 1 and quadrant 3. Okay. Next, I key in second tan 1.2435. Second tan 1.2435. 51.1943. To the nearest degree, that would be 51 degrees. This is our reference angle. So our reference angle is 51 degrees. In quadrant 1, the 51-degree angle is its own angle. In quadrant 3, we would have to take 180 plus 51 to get an angle measure of 231 degrees. If I think about this, I'm in quadrant 3 with a 51-degree reference angle. What angle shares the same terminal side as that? It's 180 plus 51, 231. Next, number 4, we have the tangent of theta is equal to negative 0.8731. What are the two possible values of theta? Well, first, this decimal value is negative. Tangent is negative in what quadrants? Quadrant 2 and quadrant 4. Next, we find the reference angle. Step 2 is to find the reference angle. So we key in second tan of 0.8731. We don't key in the negative, right? We key in the positive value, 0.8731. So second tan 0.8731 to the nearest degree, 41 degrees. So our reference angle is 41 degrees. In quadrant 2, if we had a reference angle of 41, it would share the same terminal side as 180 minus 41, which is 139. And in quadrant 4, if we had a reference angle of 41 in quadrant 4, it would share the same terminal side as an angle measure of 360 minus 41, 319. So there are two values for theta, right? Now, if I simply take, okay, 139 and key that in for theta, meaning if I take the tangent of 139, it should come out to be close to this decimal of negative 0.8731. All right, so there we go. It's negative 0.87. Right? Oh, sorry. It's not going to be spot on because we've done rounding here. All right, but it should be close, which it is. Okay, and the last one, cosine of theta is equal to 0.5582. What are our two angle measures that have a cosine of 0.5582? Well, this decimal value is positive. Cosine is positive in what quadrants? All students take chemistry in quadrant 1 and quadrant 4. Next, we want the reference angle. So we key in second cos of 0.5582 on their calculator. That's 56.0685. I'm just truncating, I'm not rounding here. So again, this is 56 degrees. This is our reference angle of 56 degrees. In quadrant 1, reference angle of 56 degrees is its own angle. And in quadrant 4, we would take 360 and subtract 56 to get 304. And this concludes our video for tonight. Thank you very much.